Welcome to the deep dive. You know, there's that question, right? That sort of nostalgic feeling. Dude, where's my starship?
Yeah.
We all saw Back to the Future, the flying cars, the cool shoes. We imagined being on the Enterprise, beaming messages across the
Oh,
galaxy.
absolutely. Those images are powerful.
But here we are. We've got amazing tech, incredible advancements. Yet, that future feels kind of distant still. Why is that?
Well, that's exactly what we're digging into today. This isn't just about listing what we don't have.
Right.
We're going to explore the real reasons, the deep-seated ones, why those visions haven't fully happened. But more importantly, we'll look at the cutting-edge stuff, the revolutionary thinking that's actually bringing us way closer than you might think.
Yeah.
It's like we're stepping beyond our current limits, technologically and, well, societally too.
So that's the mission for this deep dive then. We unpack the obstacles,
Yeah.
reveal the surprising tech that's already here, or close to it, and then try to weave it together. A vision for energy, making stuff, interstellar travel, and what it all actually means for us,
Let's do it. A journey beyond the usual.
All right, let's start with the big roadblocks. What are the main things, the sort of foundational systems that have really held us back from that Star Trek future?
Okay, well, if you look at the big picture, there are a few really ingrained systems that have maybe paradoxically slowed things down in some ways. The first big one, the combustion engine. I mean, think about it. For something like 400 years, burning stuff has been our main way to get power and move around.
400 years.
Wow. Yeah. And it evolved fast for a while, but then you get to, say, 1954, the Wankel engine. Rotary design, still used in some BMWs today.
Right, I've heard of that.
But since then, since 54, the core idea hasn't fundamentally changed all that much. We're still basically polishing a design from the mid-20th century.
Well, computers went from room size to fitting in your pocket.
Exactly. Computers, biology, astronomy, rockets even. They've all leaped forward. So why are we still refining a 1954 engine concept? That stagnation is, well, it's significant.
That really puts it in perspective. It's like everything around the engine got upgraded, but not the engine itself. Okay, so what else?
Another huge factor, kind of invisible but shaping everything, is the gold standard. Or, well, the idea of gold as the basis of value.
Okay.
For over 2,500 years, this one shiny metal has underpinned our whole global value system.
2.5 millennia.
Yeah. And if you trace it back, gold is deeply tangled up with poverty, death, war, all through history.
Yeah.
It makes you ask, does it really make sense? Basing our entire economy on a metal that just happens to be a certain color, what does that do to how we think about value?
It sounds abstract, but like you said, the consequences are incredibly real, violent even.
Precisely. And that connects directly to the third big obstacle, the constant fighting over land and resources. It's everywhere. Conflicts over territory, holy lands, indigenous lands, and crucially, fighting over natural resources like oil.
To fuel those combustion engines we just talked about.
Exactly. It's all connected. These fights are baked into our current energy and economic models. It creates this cycle of scarcity, competition, conflict.
So putting it all together to really unlock our potential, to get those starships, we need to move beyond these, frankly, outdated systems. It sounds like a massive shift, a paradigm shift, really.
That's a good way to put it, a paradigm shift.
Okay, but here's where it gets really interesting. Because while those obstacles are real, the last decade or so has seen some absolutely profound breakthroughs. And remember, a lot of this source material goes back to around October 2011.
Right, so even then,
we were standing on the edge of something completely new.
we really were and still are. I mean, if you look across different fields, the advances are pushing us into territory that used to be pure science fiction.
Like what? Give us some examples.
Okay, take biology. Dr. Sonia Kandena's work, she found that something like 98% of our DNA, the stuff often called junk DNA, doesn't actually code for proteins.
Right, the mystery DNA.
But her theories suggest it's not junk at all. It might be incredibly dynamic, changing constantly, moment to moment. This could allow for really rapid evolution, almost instantaneous adaptation.
Wow. So our genetic code isn't fixed.
Yeah.
It's adaptable.
Far more than we thought. It opens up possibilities we couldn't even imagine before. And we've seen early steps in, say, genetic life extension. Walter Yongo at USC kept yeast cells alive like 10 times longer just by switching off one gene.
Incredible. So we're learning to sort of tweak our own biology. What about our senses?
Even perception is evolving. There's sonar sight technology being developed. It mimics how bats or dolphins see using sound.
Autolocation, yeah.
Right, but translating that sound information directly for the human brain. And artificial retinas, they exist. They're still a bit pixelated, maybe, but good enough for someone to navigate safely, like crossing a street. We're augmenting ourselves.
That's amazing. Okay, biology's moving fast. What about nanotechnology? That's been a buzzword, but what's actually happening?
Nanotech is basically building things molecule by molecule, atom by atom. We're using DNA itself as a kind of tiny scaffolding.
DNA Legos.
Sort of, yeah. Building stable, complex structures at the molecular level. Then there are wilder ideas like nano-robot clouds.
Robot.
Tiny machines, swarms of them, that could use electrostatic charges to, surround an object and change its shape. Imagine your living room becoming your kitchen just like that.
Whoa.
Rice University built actual nanocars, single-molecule vehicles. And my friend John Oriva developed nanoceramics, building materials where the walls themselves convert the sun's heat into pressure for energy.
The building powers itself.
Essentially, yeah. And in medicine, nanobots are being designed to work right at the cell wall. Super precise interventions.
It's like engineering reality from the ground up. And communication. That's already gone warp speed, hasn't it?
Oh, absolutely. Instant global video calls, sending huge files anywhere in seconds. It's normal now. GPS finds anyone, anywhere.
Yeah, we take it for granted.
We can record this deep dive and have it available worldwide almost instantly. These portals, high-def video links, create a real sense of being in the same room across continents. We track weather like never before, rent houses online anywhere. Distance has basically dissolved.
Okay, so communication is sorted. What about looking outwards? Astronomy. Seeing more out there.
Oh, the discoveries are mind-blowing. Marcus Jansen's team found a planet 130 light-years away with an actual atmosphere. A big step towards finding habitable worlds.
An atmosphere. Wow.
And William Baroy at NASA, he's talked about countless planets just in our galaxy. Estimates suggest maybe a third of sun-like stars have at least one habitable planet.
A third? That's billions of planets.
Billions, potentially hundreds of thousands of conscious civilizations right here in the Milky Way.
Hundreds of thousands.
Yeah, and we're seeing connections too, like tornadoes in space, the fluid dynamics in gas clouds, mimicking weather patterns on Earth. It suggests deeper, universal geometric processes. Plus, we now have full 3D views of our own sun from multiple satellites.
Seeing the sun in 3D. Okay, the universe is looking bigger and more populated. Let's get to the really weird stuff, though. Physics. Is our understanding of reality itself changing?
That's where things get really fundamental. We're seeing these unified field theories emerge, trying to connect everything.
Like Einstein's search for.
Exactly. My personal favorite, Nassim Harameyn's Schwarzschild proton theory. It suggests that every single proton, the heart of all matter, contains a tiny black hole.
Every proton. A black hole.
And that all these mini singularities are connected through a network of wormholes, allowing for instantaneous information transfer across the entire universe.
Okay, hold on. Instant information. Everywhere.
That's the model. It's radical, faces pushback from conventional physics, sure, but it suggests you can model the whole universe from the geometry of just one proton.
That's a lot to take in.
It is. Then you have things like DNA teleportation. Luc Montagnier, the Nobel laureate, he recovered DNA patterns in water that didn't physically contain the DNA just by having it nearby in an electrical field.
So the information, the pattern, was transferred without the physical molecule.
Seems like it. And quantum teleportation at Fermilab, they achieved 89% information transfer over 10 miles, not beaming people yet, but the information, the blueprint, is moving without physically traveling.
Okay, my brain hurts a little now. If information can travel like that, it changes everything. What about the fun sci-fi stuff? Is any of that real?
Oh, yeah. Plenty of fun stuff has happened. Invisibility cloaks. They're being made with special calcite crystals that bend light around an object. Poof, it's gone.
Seriously. Invisibility.
Work in progress, but yeah. We also have phonons, or sound lasers. They can project sound so precisely only one person hears it, or just within a specific spot, even far away.
Personal sound bubbles.
Kind of. Real-time, dynamic, holography, interactive 3D images in mid-air that's being done at the University of Arizona.
Like in Star Wars.
Getting there. And maybe most relevant for our Starship chat. Singularity University and NASA worked on a mind-computer interface. You control a 3D avatar just by thinking. Think, jump, it jumps.
Mind control.
For avatars, yeah. But think of the implications. Controlling robots on Mars, maybe even piloting a starship directly with your thoughts.
Okay, so biology, nanotech, communication, astronomy, physics, incredible leaps everywhere. But, and it's the big but, like you said earlier.
We're still putting gas in our cars.
Right, we're still stuck in these older systems. So how do we bridge that gap? How do we revolutionize energy and replication?
Exactly. Those are the keys. Despite all this amazing tech, our energy and economic systems are lagging. We absolutely need new energy sources.
Like what?
Well, one area is water technologies. Trying to get energy from water, there's the strange story of Francis Crick back in '82. Built a water engine, BMW tested it, then it vanished by '88, patent expired later.
Vanished.
Yeah, and Gene Pax had a water car around 2008. His website shut down fast. Then you have HHO electrolyzers splitting water into hydrogen and oxygen to burn.
Right, hydrogen fuel.
Kind of, but burning the mix directly. Efficiency is debated, and there's big pushback from groups like the Automobile Association. Researchers report funding drying up, lots of resistance.
Sounds familiar.
Yeah.
New tech threatening old industries.
It's a pattern, but solar is definitely moving forward rapidly.
Yeah, solar panels are everywhere now.
And getting better, NanoSolar is working on printable solar cells. You could coat almost anything fabrics, windows turn any surface into a generator.
Wow.
Plus concentrated solar power, huge fields of mirrors focusing sunlight to a single point, creating immense heat for power, like the NextEra plant in Arizona, 5 megawatts just from sunlight.
Okay, solar's getting powerful. What about the really out there stuff like cold fusion? Low-energy nuclear reaction? Sounds like alchemy.
LENR, yeah. It's had that mythological feel, definitely. Remember Flashman and Pons in the 80s? Big controversy. They claimed nuclear reactions at room temp using hydrogen, water, palladium, releasing heat.
Right, huge debate, then they kind of disappeared.
Yeah. But the U.S. Navy acknowledged looking into similar effects in 2002. Yoshiaki Arata demonstrated a working experiment in 2008. By 2011, NASA Langley called it interesting and promising new tech. There's even a researcher on Kauai working on stabilizing it with lasers. It's quietly moving forward.
Interesting. So maybe not mythology after all.
Yeah.
Okay, for breaking nuclear barriers. What about the ultimate source?
Right.
Zero-point energy. Tapping the vacuum.
Zero-point energy. That's the potential game changer for truly limitless power. It's theorized to be this incredibly abundant energy everywhere, constantly bubbling in and out of existence in the quantum foam of space-time, especially strong in magnetic fields.
Energy from nothing, or from everything.
From the fabric of reality itself, yeah. People are trying different ways to tap it. ZP magnetics, rotating magnets in special ways. Implosion systems based on Victor Schauberger's vortex ideas, drawing energy in. Yeah. And polar cone resonators spinning metallic cones to resonate with the ZP field.
Okay, limitless energy changes the game entirely. But what about stuff? Physical things. We have 3D printers, but you mentioned something more like Star Trek replicators. How do we get from plastic trinkets to a hot cup of coffee appearing out of nowhere?
Right, the replication revolution. 3D printing is just the baby step, building layer by layer. The real goal is true replication, building anything directly from the fabric of space-time. Instantly make a cappuccino, a meal, a machine part.
How on earth?
Several paths are being explored. Excimer laser lithography uses lasers to shape molecules precisely. Molecular beam epitaxy, Shark Labs, Oxford are working on this, uses lasers to carry and place molecules, building atom by atom. Think super complex circuit boards.
Atom by atom construction.
Then nanobot construction. Boris Fritz at Northrop Grumman was looking at swarms of nanobots assembling things from raw materials.
Microscopic factories again.
Yeah.
But what's the ultimate version?
The next level involves sematics, the science of sound creating geometric patterns, using sound lasers to imprint complex geometries onto molecules.
Sound shapes matter.
It can. Then an MBA, geometric array, basically precise lasers, shoots these structured molecules into place. Molecular sculpting, Timothy Lear's work, uses sound and light to position them in 3D.
Okay, getting very complex.
But the ultimate is integrative replication at the Planck scale, directly manipulating space-time itself, the quantum foam, the tiniest level of reality.
Whoa.
At that level, you could theoretically turn any atom into any other atom. You wouldn't just copy the molecules of, say, a tomato. You'd copy its entire energetic structure, gravity, electromagnetism, heat, maybe even its life force.
So it wouldn't just be like the original tomato.
It would be the original, energetically identical. You could turn landfill into soil, anything into anything else.
Okay, if we can do that, make anything from anything, what happens to our economy? Our whole idea of value based on scarcity.
It goes out the window.
Yeah.
Completely. If you can replicate gold, diamonds, anything,
Yeah.
their material value vanishes.
So what has value then?
Value shifts. It becomes about social contribution, artistic creation, ingenuity, the skill of the barista making the perfect coffee, the knowledge of the gardener who grew that perfect heirloom tomato you replicate. The value becomes what you uniquely have to give, to share, to create.
That's a profound shift in thinking from material wealth to creative wealth.
Exactly.
All right, this is amazing, but it loops back to the big question.
Yeah.
How do we get there? How do we travel to other worlds if, as you said, rockets are too slow?
You're right. Conventional rockets, even advanced ion drives or plasma engines, they're just not practical for interstellar distances.
Oh, yeah.
19,000 years to the nearest star, that's basically standing still on a galactic scale.
Pushing pencils through the fabric, you called it.
Yeah. And the physics is tough. Accelerating creates artificial gravity, warps space-time. You need infinite energy to hit light speed. And time dilation gets extreme. You arrive 5 minutes later, but everyone back home is long gone. We need to work with the fabric, not push against it.
So bypass the speed limit somehow.
Yeah.
Anti-gravity, warp drives. Is that real?
Well, the ideas are out there. Groups like the Disclosure Project claim the military developed anti-gravity tech ages ago. Theoretically, people talk about needing negative mass to curve space the other way.
Negative mass sounds impossible.
Some say it needs contrived circumstances, but contrived just means cleverly engineered, right? NASA's Breakthrough Propulsion Physics program looked at things like diametric drives. And the Alcubierre warp drive is famous contracting space ahead, expanding it behind.
The Star Trek warp bubble.
Kind of, yeah. But it needs theoretical exotic materials we don't have.
Okay, so those are the big, maybe distant ideas.
Yeah.
What about working with space-time, like you said? A different approach.
This is where field resonance propulsion comes in. Alan Holt at NASA proposed this back in 1979.
Resonance.
Like tuning forks.
Exactly like tuning forks, but with space-time itself.
Yeah.
The idea is to pulse electromagnetic fields in perfect resonance with the destination's unique space-time signature.
How does that work?
Remember, Einstein said gravity isn't a force, it's the geometry of space-time. And EMCAY means energy and mass are equivalent, so light can bend space-time, theoretically. Holt connected this to things like solar flares, huge magnetic fields releasing massive energy, maybe causing gravitational waves.
So you tune your ship to the destination's frequency.
You learn its harmonics, gravity, light, geometry. You resonate your ship's field to match.
Yeah.
Then space-time itself sort of shifts you there, like quantum superposition, but on a macro scale. Instantaneous arrival.
Instantaneous. Wow.
Yeah.
Less like flying, more like just appearing.
Pretty much. Unfortunately, funding to measure gravitational waves directly got cut, which slowed this line of research.
Always the funding. Are there other related ideas?
Well, Ronald Mallet suggested using ring lasers to twist space-time, maybe create a wormhole for time travel. But the key idea is creating a singularity with light. And that connects back to Harmeen's theory.
Exactly. If Nassim Haramein is right, and every proton already has a singularity, a wormhole connection, then the job's half done. Wormholes might be everywhere, linking everything. The goal isn't time travel, it's instantaneous present-to-present jumps.
So understanding the deep structure of space-time is the key, not brute force.
Precisely. Think about diamagnetism. We can levitate a frog with magnets. That shows magnetism interacting with gravity locally. It hints that space-time isn't empty, it's a structure, a lattice of energy geometries. String theory, M theory, Luke quantum gravity, they all describe this fabric. If we understand the weave, we can use light and fields to navigate within it, maybe faster than light.
Okay, mind officially blown. Let's try to pull it all together then. If we combine these ideas, ZPE, replication, resonance physics, what does a starship actually look like? It sounds impossibly complex.
But maybe it's elegantly simple once you grasp the principles. Think about it. Power source, zero-point energy. Capture via scalar resonance, tapping the chi of those universal wormhole connections.
Limitless power. Navigation.
Direct mind link. A holographic display, like that Celestia software, but interactive. You pilot by thought, by mental projection. Imagine yourself there, the ship follows.
Just think your way across the galaxy.
Essentially. You'd have a library of destination harmonics and pulsars. They're like stable galactic GPS beacons. Their predictable timing lets you calculate precise connection points, even accounting for light delay across vast distances.
So you'd know exactly where there is right now. And life support.
Replicators handle that. Plenty of coffee and tea. And inside, an internal field resonator creates comfortable gravity. You could even turn it off for zero-G fun.
Nice. Okay, the drive itself. That gravitational envelope you mentioned, how does it make the jump?
It's like a standing wave of light, creating a barrier, a mini ring of singularity. It separates the ship's internal space-time bubble from the outside. It basically tells external gravity, nothing to see here.
So it negates gravity's effects.
Exactly. No inertia, no g-forces. Then, another external field resonates with the destination's frequency, telling the fabric of space-time, the ship is now here. It doesn't accelerate through space, it slides through the fabric like a bubble. Instant jumps or smooth variable speed without any physical stress.
Wow. So the pilot needs good mental projection skills and basic astronomy.
Pretty much. Good focus, clear intent, and knowing not to materialize inside a star. The principles are simple once you see how the universe really works, like flying a 747 complex machine, simple aerodynamic principles.
This isn't science fiction anymore, is it?
I hate-
It's like integration, pulling together what we already know or are discovering right now.
Yeah.
This changes everything.
It absolutely does. Imagine it, a near future with a kind of Starfleet Academy, learning to pilot these ships, exploring.
And society changes.
Fundamentally, art, creativity, contribution become the main currency, not survival. Imagine global tensions dropping when resources are abundant. We could focus on planetary healing, giving back to Earth, creating sustainable, connected communities. Universal well-being becomes possible. Everyone has what they need to thrive.
And we wouldn't be alone.
That's maybe the most exciting part, the potential to connect with, learn from other civilizations out there. Imagine integrating the wisdom, the art, the science of thousands of other species who've maybe already figured this out. Our culture, our potential would explode.
It's an incredible vision. So for you listening right now, what would you do? If survival wasn't the main driver, if the galaxy was open, what art would you make? What gifts would you share? Something to think about.